excited to welcome our first panel, which again is really focused around hearing from the folks who are inside, who are working at the headquarters and program office level on some of these critical challenges. And let me just lay out just a couple stats that give you an idea of the size, scale, and breadth of the DoD's push to electrify its fleet. 160,000 plus non-tactical vehicles of many different shapes and sizes. And in the president's executive order earlier this year, there was a clear marching order to expect that 100% of those vehicles be electrified in the relatively near future. I'm really excited to welcome this group of folks who are working on that issue as we speak. I'm going to go through each of them and give you a little bit of background, and then invite them to share some of their thoughts and questions. I'm going to start with Casey Harsh. Casey, first of all, it looks like you're in a more tropical locale than me, so yeah, that's exciting. Yes, yeah.
Can you guys
absolutely.
hear me okay?
Yeah, you sound great.
I just started an MBA program in Miami, Florida. My first time here, so I'm in between classes. Actually, my classes just begun. I snuck out to try and participate in this. So, apologize for the Southern California camouflage here, but that's a.
No, it's great. I mean, I think you're mostly making our audience jealous. So, but we'll accept that. So Casey is an operations officer in the Transportation Services Branch at Marine Corps Installations Command. He's also a Marine Corps veteran. He's worked in a lot of logistics, really senior logistics positions around the Marine Corps. So Casey, I wanted to start with you because you're responsible for the vehicles that we're talking about, and we're going to talk a lot about infrastructure challenges associated with electrifying this fleet for much of the rest of this conversation. But I want to start with you because you have responsibility for the vehicles themselves and working through how you're going to transform the Marine Corps fleet. So first, can you just give us a sense of the breadth and depth of what that transformation will require? What does the Marine Corps, from a vehicle standpoint, have? And non-tactical vehicles, obviously, is what we're talking about here. So yeah. What is that like? And then where do you see that future transformation sort of taking place, and what does it look like?
Yeah, so we have. I actually joined this organization back in February, and this kind of landed on my plate. I'm the lead action officer for fleet electrification. But from, like I said, we handle all the non-tactical. We manage and support and maintain all the non-tactical budget for and acquire all the non-tactical vehicles. So we have approximately 11,770 vehicles, and I pulled that from an old info paper they had. And those range from everything from sedans, minivans, SUVs, half-ton trucks, diesel, 3/4 and 1-ton trucks. That includes our buses. That includes includes even engineering equipment, dozers and graders that maintain our ranges. But or we have stake bed trucks, dump trucks. We have garbage trucks. We have emergency vehicles like ambulances, PMO vehicles, which are sedans that you've seen over there. So that's kind of the breadth of them. The vehicles that we see that are really available, that are available to us, that we can electrify, that we can transition from our standard internal combustion engine, right, legacy gas powered vehicles, are really that GSA has really offered to us that we can do, are really our sedans, minivans, and SUVs. Recently, you saw the F-150 has the Lightning, so that's kind of coming online with the model year 2022. I don't know if those are really available to us. So currently, we by and large we work through the GSA lease program, and we lease really the sedans and the minivans and those more kind of transportation, more kind of civilian type vehicles that operate and move Marines and our VFAs throughout around our bases and stations. Like I said, we use the GSA lease program, so we generally keep these vehicles for about 5 years, and then we replace them. So we kind of have this replacement cycle, approximately 230 vehicles within that light duty. When I say light duty, it's within the sedans, minivans, half-ton trucks, right? SUVs, that all kind. And that's the population of vehicles that we're targeting, that we're really first that we're going to be transitioning to electric vehicles. And so based on that, we're still trying to work out the planning, but our initial thoughts were, okay, well, as our vehicles come up for replacement, and then we'll just, and if it's suitable within the range constraints and the capabilities of the EVs, then we will just replace those vehicles that come up for replacement, and we'll instead of replacing it with a sedan comes up for replacement, instead of, if it makes sense, we can, then we'll replace it with an EV vehicle, vice purchasing, say, a standard gas powered vehicle.
Yeah, I mean that makes sense. That you're going to take a phased approach where you focus on the things that are immediately commercially available, especially through the GSA lease program. And for those who don't know, almost all of these vehicles are leased through GSA. Are you starting to think about what do you do with those, more specialized and challenging vehicles to replace?
Yeah, the thought is like, so like I said, the bigger the dump trucks, the 3/4 and the quarter and the 3/4 and the 1-ton trucks, diesel vehicles, those aren't really available right now for conversion to EVs, right? So we're kind of focused on that. We're trying to get our head around that, and then we have the constraints that have been kind of placed when we've seen some derivative executive orders that have fallen out since that initial one there on the 27th of January. That we think our first one is that I think by 2027, all of our vehicles will be well. And I still think they're focusing on light duty as of right now, because that's the only feasible EV vehicle that we can do. So based on that replacement cycle, we're still trying to see if we're going to make those time hacks and that we'll be able to electrify by then.
Perfect, Casey. I think that's a perfect summation of sort of like we said, the breadth of the fleet in the Marine Corps. I think, in many ways that diversity of vehicles is mirrored in the other services in some ways. But let's hear from some of the other folks on the panel who can get into this more. So I want to turn to Brendan Casey. Brendan's the Resource and Analysis Program Manager for Transportation at Naval Engineering Facilities and Engineering Systems Command, NAVFAC, for those of you who are working on this stuff. But Brendan brings a really great background, because previous to his position working on vehicle electrification, he and fleets in general, he was working on utility markets analysis. So he's got really important background both in electricity markets, which are going to be absolutely critical to this change and this transformation, as well as the vehicle side and as well as the budgeting side for the vehicle. So Brendan, I mean, I think, the easy question for you is, with that experience, how do you see those issues intersecting? What are the big issues that are challenging you from a Department of Navy perspective around this transformation? You're on mute, Brendan.
Spacebar is not unmuting. Okay, there we go. Thanks for the question, Michael. So I think there are two ways of looking at this. We can provide solutions tomorrow, spend money, buy vehicles, put in charging stations. We're very good at the construction side of this. But the stuff that keeps me up at night is trying to figure out big picture, how do we scale this in a more meaningful way? And we can't build the infrastructure fast enough. We have quite a lot of EVSE across the Navy right now, being used to varying degrees depending on the location you're talking about. So how do we work with private sector partners? Really interested in trying to crack the nut on energy service companies, energy aggregators. How do we shift the culture and the mindset of thinking of EVs as a liability, like we do with most of our vehicles, and see them as an asset? What else can they be doing when they're not being used? And that can be done. It's being done in academia and the private sector, but there's a lot of wickets to go through in trying to connect the dots there in a government setting. But the energy security benefits are there. And we're trying to figure out how to do that now. So lots of exciting discussions about pilot opportunities and how we can try to avail ourselves of amazing technology that's coming online now. But it remains to be seen how exactly we're going to navigate that space. So really looking forward to the forum here. Thanks for inviting me.
Yeah, Brennan, let me dig a little deeper on that, because you worked on the Anchor program previous, and so you were really taking a look at analyzing and understanding installation utility bills and understanding how we can really maximize the value streams coming out of installation assets. So lay out a couple of the value streams that you see for electric vehicles that are sort of that you think are going to be high potential values in the future.
That's also a good question. I think, like, right now our fuel situation is sort of a black hole. We spend a lot of money on fuel and it's seen as a sunk cost, that we use this fuel to run the non-tactical vehicle fleet, and it is what it is. We don't have great fidelity in the data side of that. Like, how much fuel are we using? Where is it being used? What is that overall bill at the end of the year? And the fidelity we get by electrifying substantially that non-tactical vehicle fleet would be exponential compared to the status quo. And so trying to create parity between how we're looking at status quo NTV operations versus what the future could be with majority electrification is going to be a huge value add in we're going to have to do a lot of systems work on trying to figure out how do we rework with what we have. But I think that data quality side of things, particularly marrying up the mobility energy use and the shore infrastructure energy use into a holistic energy portfolio, is what we're driving towards. And difficult thing to do, but exciting to be involved in it.
Yeah, that's perfect. I mean, I think that's and that's a perfect segue to turn to Doug Tucker, who's for purposes of full disclosure, a really close friend and mentor to me and past colleague in the Air Force. So Doug is the Director of Installation Energy Policy and Programs at the U.S. Air Force. Doug, I know you are both involved in obviously setting policy and plans for how the Air Force is going to pursue this transformation, but you're also working as a part of the administration's broader policy development for how it's going to electrify its federal fleet, which again is more than 600,000 vehicles, out of which 160,000 are DoD controlled. So, that's a great prompt to ask you, Doug, how you are viewing the issues that are particular to DoD in some of the classification challenges and things like that for EV, electric vehicle support equipment that Brennan mentioned earlier, but also how are you thinking about some of the issues that are not related to DoD, but are more related to sort of broader federal electrification?
Yeah, thank you, Mike, for the introduction and for the invitation. Being part of the CEQ team has been real exciting for me because I have met some big thinkers that are attacking this. And as a member of the Sprint team, we kind of bring the operational and the tactical type to the theoretical discussion. And I think that's very important because when we look at the numbers as an aggregate, they're big. Within the Air Force, it's 76,000 vehicles, but they're spread all over the world. Some of them are 1 or 2 deep at a recruiting station, and some of them are concentrated, hundreds at an installation. And so we're trying to balance where we can make this attractive to industry and not do vehicle replacement by vehicle replacement at their location, but how can we replace those and consolidate them and bring them together so it's a meaningful opportunity, both in the various departments investment, but also getting industry interested in coming in, because we're really excited about the acquisition opportunities like charging as a service. What policy challenges has that presented for us? First of all, if we do third party, we got to bill people for the electricity. We've got to bill the individual agencies, just like we did for the fuel. How do we collect that point of sale? How do we get it to the right appropriation to then pay for that capital investment or that electricity? We're kind of nugging through that right now in the discussion. That's further complicated by how do we classify the equipment? If it's not real property, who buys it? Who maintains it? Who gets the authority to operate or the credentials from a cyber perspective? Those are the type of issues that we're discussing with our counterparts in the other federal agencies as part of the Sprint team. And we're looking at policies that exist today that are hindrances and those that give us the opportunity to exploit. For example, the ESPC, the UESC, utilities privatization, and how do we partner with them and bring it in. Those are kind of the policy initiatives that we're nugging through. Certainly the president's initiative is broader than the federal agencies, but the split team and the work that we bring is, okay, how are we going to implement this? Not from the enterprise aggregate big number of 10% of the vehicles of 76,000, but how are we going to get a synergy and roll this out in a smart way? And I'd also like to close with, remember, DoD is all about mission. And so how does that generation, storage, the criticality of that vehicle to that asset fit in the system of systems that is our distribution network? How can we exploit that to ensure that we can maintain the mission capabilities? But thanks,
Doug. Yeah, and you couldn't have provided a better segue to talk with Tim Pennington, who is the Senior Research Engineer for Vehicle Electrification at the Idaho National Laboratory. Because Tim, this is what you spend all your time on. You know, what Doug works on from an installation policy and sort of distribution system, understanding standpoint is what you work on trying to model out at individual facilities and campuses and things like that for this transformation. Because, my understanding is that if we're going to deploy charging, it is going to be a tremendous new load on our distribution systems on military bases, which are already dilapidated would be a kind word in many cases. So Tim, I guess, my question to you is, you heard some of the challenges, but like, what out of that gives you some, what on that are you working on? What on that do you think is most urgent from, and then what on that gives you some sort of optimism and hope that we can turn this kind of thing around? Tim, we're not hearing you. You might be double muted.
Can you hear me now, Michael? Good, great. Apologies for that. Thank you for inviting me and for the intro. As a national lab, working for the Department of Energy, Idaho National Lab's been working on electric vehicles for decades. In the 90s, it was kind of a science project, and Nissan brought out the Leaf, let's explore that. I'm really interested now and super excited with the current administration push and the buy-in that we're getting from all the different agencies and industry as well, that we'll be able to take the experience we have and the research we've done and the lessons we've learned and apply that. We need to find the right way to transfer that knowledge. I've had the opportunity to hear Doug speak before at the Energy Exchange. And actually, I think Brennan and I were both on a day-long workshop yesterday with Miramar about electrification. So I am gaining a perspective about these challenges. And I think the Department of Energy and the National Lab Complex, props to NREL and Argonne and Oak Ridge, who also work on these projects. We all have a lot to offer that can help with some of these challenges that we're hearing. So I'll just touch on, 3 key areas that I think we have a lot to offer. The policy issues are kind of unique to the agencies and federal government and whatnot. We're happy to be involved in those discussions because I think the technology needs to inform the policy as to what is possible and how we can improve that, point of sale and tracking and communications. But the areas we're focused on that I think are also important are about energy management. So as Michael pointed out, INL has developed a tool called Caldera. We represent every vehicle and every charger as an agent in a simulation, and we're tracking their loads. And each type of vehicle obviously has a different battery, and each user shows up at the charger at a different point in their battery charge. And all of that impacts what your load actually looks like on the grid and what your distribution network is going to see and be capable of. I'll just say, DOE for a long time has done studies about, can we meet the demand for the power that electric vehicles are going to, require? And every study I've ever seen says, yes, that's what the private industry has always done in energy generation. As demand increases, we match that. But the question that's more important to me is, can the local distribution match the local load? If I go and put 6 fast chargers down in one spot, as Genevieve said, those are at 350 kilowatts. That's a new small hospital that just showed up on my base or at my street corner or wherever. How do I account for that? So lots to be done there. Opportunities with local energy storage next to the chargers, or charge management that schedules when charges happen throughout the night or off-peak times, or consumes local renewable generation. Other key areas that the national labs have to support cybersecurity, we're doing a lot. Idaho in particular does a lot on critical infrastructure cybersecurity, and we're treating electric vehicle supply equipment as a critical infrastructure, appropriately, I think now, and doing a lot of studies about, if we're going to have those cool energy management communications, how do we secure it? Because if some adversary gets in there and starts to, act improperly, Idaho has shown that a rapid stop charge of 6 of those fast chargers could easily, cause a divergence from standards for the utility. So those need to be secure. And as Doug was pointing out, that's a good question of who's responsible for that. Is that facilities, or is that the fleet manager? Who's maintaining that on a regular basis? And then finally, energy storage, both in the vehicles, and if we get into using the vehicles as a distributed energy storage source where they're providing bidirectional power flow, we need to be considering what happens to those batteries over time. So INL in particular has some real battery expertise that are doing battery aging, shelf life aging, but also usage aging, and developing mitigations. There are, you could substantially extend the life of your battery. I'm talking 25, 30% life extension just through managing how you store the battery. Do you charge it up in the evening and then leave it full all night, even though your driver doesn't need it until 6 a.m.? Or do you charge it at 3 a.m. so it's ready at 6? That could have a substantial impact on the value over time of these assets. So
yeah, thanks, Tim. I think just drawing together, the last 3 speakers, I think is really remarkable, because what Brendan has been working on around, identifying value streams, understanding, how we're going to interact with utilities around two-way charging and treating these things as an asset. What Doug's talking about how not just in the federal fleet, but we're all in this together, right? Like, this is something that companies are going through, something that universities are going through, something that small cities and states are going through. And I think it's going to be a fascinating, path forward that I think is critically important. We have hopefully more forums like this where we can share some of that understanding and what we're learning. Unfortunately, we're out of time. But let me first thank Doug, Casey, Brendan, and Tim for really remarkable contributions. And we look forward to working with you more in the future. So thanks so much for for joining us today.
Thanks for having me.